Hello everyone. Welcome back to the channel. Today we're going to understand a clean and interesting array problem from Leetcode. Minimum removals to balance array. You are given an integer array called nums, an integer value k. Your task is to remove the minimum number of elements from the array so that the remaining elements form a balanced array. Important constraint. You are allowed to remove elements, but the array must not become empty. What does balanced array mean? An array is considered balanced if maximum element lesser than k into minimum element. In simple words, take the smallest number in the array, multiply it by k. The largest number in the array must be less than or equal to that value. Special case. If the array has only one element, it is always balanced. Why? Because the minimum and maximum are the same. So the condition will always be true. Objective. We want to remove as few elements as possible, so that the remaining array satisfies the balance condition. Finally, return the minimum number of removals required. Let's understand the examples one by one. Example 1. Input is the array of 2, 1, 5. The value of k is 2. Output. 1 must be removed. Explanation. We look at the array and check whether it is balanced. The minimum value in the array is 1, and the maximum value is 5. To be balanced, the maximum value must be less than or equal to the minimum value multiplied by k. 1 multiplied by 2 equals 2. Since 5 is greater than 2, the array is not balanced. To fix this, we remove the element 5. The remaining array becomes 2 and 1. Now, the minimum value is 1 and the maximum value is 2. 1 multiplied by 2 equals 2, and 2 is less than or equal to 2. So the array is now balanced. Only one element was removed, which is the minimum possible. That is why the answer is 1. Example 2. Input is the array of 1, 6, 2, 9. The value of k is 3. Output. 2 must be removed. Explanation. First, we identify the minimum and maximum values. The minimum value is 1, and the maximum value is 9. 1 multiplied by 3 equals 3. Since 9 is greater than 3, the array is not balanced. We remove the smallest element 1 and the largest element 9. The remaining array becomes 6 and 2. Now, the minimum value is 2 and the maximum value is 6. 2 multiplied by 3 equals 6. Since 6 is less than or equal to 6, the array is balanced. We removed 2 elements in total, which is the minimum required. Therefore, the answer is 2. Example 3. Input is the array of 4 and 6. The value of k is 2. Output. 0 need to be removed. Explanation. The minimum value in the array is 4, and the maximum value is 6. 4 multiplied by 2 equals 8. Since 6 is less than or equal to 8, the array already satisfies the balance condition. Because the array is already balanced, no elements need to be removed. That is why the answer is 0. Okay, let's walk through this solution step by step and understand how the code works. First, we sort the array. Sorting is important because once the numbers are in increasing order, the smallest element will always be on the left side and the largest element will be on the right side. This makes it very easy to track the minimum and maximum values of any subarray we choose. Next, we store the total number of elements in a variable called total_elements. We also initialize 2 pointers called start and end. These pointers represent a sliding window. The idea is that the window will always represent a candidate balanced subarray. We also maintain a variable called largest balanced size, which keeps track of the maximum number of elements we can keep while still satisfying the balance condition. Now we start moving the end pointer from left to right through the array. For each position of end, we check whether the current window is balanced. Since the array is sorted, the minimum element of the window is always nums, start, and the maximum element is nums, end. So we simply check whether nums, end, is less than or equal to nums, start, multiplied by k. If this condition is satisfied, it means the current window is balanced. In that case, We calculate the size of the window using end minus start plus 1 and update largest balance size if this window is larger than what we have seen before. After that, we expand the window by moving the end pointer forward. If the condition is not satisfied, it means the window is no longer balanced because the maximum element has become too large compared to the minimum. Since the array is sorted, increasing the end pointer further will only make the problem worse. So instead, we shrink the window from the left by moving the start pointer forward. This effectively increases the minimum value and helps restore the balance condition. We repeat this process until the end pointer reaches the end of the array. By the time the loop finishes, largest balance size will store the size of the largest balanced subarray that we can keep. Finally, to compute the answer, we subtract the size of the largest balanced subarray from the total number of elements. This gives us the minimum number of elements that must be removed to make the array balanced. In summary, this solution uses sorting and a sliding window technique to efficiently find the largest balance group of numbers. By focusing on what we can keep instead of what we remove, we achieve an optimal solution with good performance and clean logic. Let's run the code and verify that it correctly returns the minimum number of removals needed to balance the array. And passed. Since the solution is efficient, easy to understand, and works within the required constraints, we can confidently submit this solution. And accepted. That's it for this problem. Today we learned how changing our perspective from removing elements to keeping the largest valid group can simplify a problem significantly. We also saw how sorting combined with a sliding window technique leads to a clean and optimal solution. If you found this explanation helpful, make sure to like the video, subscribe to the channel, and share it with someone preparing for coding interviews. Given the solution link in description. See you in the next problem.